Dear students, here we start with lecture 16 of Math 303. You should be aware of the previous lectures and get prepared all those lectures which I have taken, because the next lecture which I am taking or just I am taking or in future I will take, all these are depends on the previous lectures which I have taken. So all the time you have to keep in mind that you have to thoroughly follow the lectures which I have delivered. So by guessing that you are already done the previous work, that I keep in mind and going further in the syllabus. So now it is your responsibility to take the charge of the all previous lectures. So with that note, I start with new lecture. Example 7 as per my note. Find the Fourier series of fx equal to x in minus pi to pi. Obviously the interval will be minus pi to pi because this is in the base of definition. So let's start. Fx equal to x, this is odd function. You know that what is odd and what is even. The function for which fx equal f of minus x equal to fx, this is even function. F of minus x equal to minus fx, the definition is odd function. So you know that very well about this one. The function for which f of minus x equal to fx, even functions are x square, x raised to 4, 10x, or any even power of x will be considered as even function. Even mod x is a even function. Odd functions x, x cube, x raised to 5 means any odd power will be odd function. Sin x is odd function. So this is fx equal to x, this is odd function. So if you remember the definition of Fourier series, an equal to minus pi to pi 1 upon pi fx cos nx dx, and fx equal to x means this is x. Now this is odd function and therefore this is equal to 0 for all n. So we have to consider here only bn 1 upon pi minus pi to pi x sin nx dx. As this is even function, this is equal to 2 upon pi 0 to pi x sin nx dx. I suggest you to keep writing with me. Whenever I am writing on the board, you should write in your notebook. Now this is formula for integration by parts. Means integration uv, that is u integration v minus integration differentiation of u integration of v and integration of o. So in this we choose u equal to x, v equal to sin nx. So 2 upon 5 2 u remain as it is. Integration of sin nx is minus cos nx upon n. Limit is 0 to pi. 0 to pi differentiation of x is 1 and that of sin nx is minus cos nx upon n. Due to that, this minus sign becomes plus. Now in further calculation, you know that now this is integration of cos nx upon n. Now integration of cos nx is sin nx upon n. So if we put the limit 0 or pi at both these places, cos function is 0, sin function is 0, and therefore this term will not be in calculation furthermore. See here what happened that this is 1 upon n, 0 to pi cos nx dx. Now what is integration of this term? Is sin nx upon n, 0 to pi. So sin pi is 0, sin 0 is 0. So this term is not in calculation. So I do not consider the second term. So we focused only on the first term. So this is equal to 2 upon pi. I put this sign of minus outside of this bracket. Pi cos n pi upon n the second term is 0. X is 0. First is n, x equal to pi is pi cos n pi upon n. In the second one it is 0, cos n into 0. So this is 1, but this is multiplied by 0 and therefore it is not in the calculation. So this is equal to pi will be cancelled. Minus 2 cos n pi. So this is equal to minus 2 minus 1 raised to n. You know that what is cos pi? Minus 1. Cos 2 pi 1 means it is minus 1 square. What is cos 3 pi? It is minus 1. Minus 1 cube. What is cos 4 pi? It is 1. Minus 1 raised to 4 and therefore this is happened. I can write this as I increase the power of minus 1 by 1. Minus 1 raised to n plus 1. And therefore this is value of Vn. Now see the formula of odd functions for Fourier series in 6. Go. Therefore, fx equal to sigma Vn sin nx. N is running from 1 to infinity in minus pi to pi. So it is V1 sin x, V2 sin 2x, V3 sin 3x, V4 sin 4x, V5 sin 5x and likewise other. Now if we put this is it. If we put n equal to 1 This is 2 upon 1 means it is 2 minus 1 raised to 1. Minus 1 square means it is 1. So it is sin x, 2 sin x. Then I put n equal to 2. So this is minus 1 because minus 1 raised to q. Minus 2 upon 2 sin 2x. Then n equal to 3 plus 2 by 3 sin 3x. Then n equal to 4. N equal to 4 means 2 by 4 sin 4x. Then n equal to 5 and other terms. This is if we take 2 in common. Sin x minus sin 2x upon 2 plus sin 3x upon 3 minus sin 4x upon 4 plus sin 5x upon 5 and other terms. This is Fourier series expansion of x. Clear? Next we want to find Fourier series expansion of fx equal to x square. This is even function. Again keep in mind the definition of Fourier series. If fx equal to x square is even function, then the Fourier series expansion in which bn are 0. Is even function. Therefore, all bn equal to 0. And value of an is equal to 1 upon pi minus pi to plus pi x square dx. Therefore, this is equal to 1 upon pi x cube by 3 minus pi to plus pi pi cube by 3 so 2 pi square by 3. This is value of a0. Next we want to find value of an. See here, this is 0. This is n, means it is for all n. If you put n equal to 0, this will be cos 0, and cos 0 is 1, so it is not in calculation. Okay? So this is, again we are going to apply this formula. So this is equal to 1 upon pi x square sin nx upon n minus pi to pi minus 1 upon n See here, u is x square and v is cos nx. U means x square as it is. Integration of cos nx is sin nx divided by n, minus differentiation of u means 2x, integration of cos, that is sin nx upon n. So we may take 1 upon n outside of bracket, that we can do. Here, if you put phi, sin phi 0, sin minus phi 0, see this term is having value 0 at both the times, and therefore this is 0 minus 0. So this value is 0, therefore it is not in any calculation. This is equal to so now we have to deal with this sum. So this is equal to, again here we take and we are going to apply this formula. We are going to apply this formula. So this is equal to minus 2 upon n pi see here, u as it is, u is x, integration of sin is minus cos, and x is there and therefore we divide it by, actually there is minus, but differentiation of x is 1, integration of sin is minus cos, and though it is minus, minus becomes plus, so it is cos nx upon n. Now integration of cos is sin, and at pi it is 0, at minus pi sin is 0, and therefore this term is not in any calculation. So we have to deal with only this part, and therefore minus minus becomes plus. So it is 2 upon n pi. Now if we put x equal to pi, means pi cos n pi upon n, then minus pi, minus of minus pi cos n minus pi, but cos minus theta is cos theta upon n, so we have this term, minus minus becomes plus, and therefore this term is double. Therefore it is 2 pi cos n pi upon n, so it is 4 upon n square pi cos n pi. So therefore n equal to 4 upon n square pi minus 1 raised to n. That you know how it is. And therefore fx equal to 1 by 2 a0 plus sigma an cos nx, n is running from 1 to infinity. This formula you can find there in the 6th of Fourier series. So this is equal to a0 2 by 3 pi square plus a1 4 upon pi n equal to 1 means cos x, and this is with minus sign, plus 4 upon 2 square phi cos 2x plus 4 upon 3 square phi. At third term this is negative because minus 1 cube cos 3x plus 4 upon 4 square pi cos 4x minus 4 upon 5 square pi cos 5x and other terms. So this is equal to we can cancel out this pi also, and therefore we can find x square equal to pi is there. So you can cancel out this pi, and therefore 4 upon n square minus 1 raised to n, and therefore we can cancel out this pi from each of the term. So this is equal to pi square by 3 plus 4 minus cos x plus cos 2x upon 2 square, 4 is outside, minus cos 3x upon 3 square plus cos 4x upon 4 square minus cos 5x 5 square and other terms. So this is approximation of x square. Okay, I stop here for this lecture, but we continue in this next lecture by this term. Thank you very much.